Dividing radicals, there are 3 steps over here: reduce fractions, simplify radicals, rationalize the denominator. Now we may have to repeat these steps as needed. And the first 2 can be done in any order. I usually like to reduce fractions first, but you can simplify radicals first. In this example though, I am going to start by simplifying this radical because it happens to be a perfect square. The square root of 64 we know is 8. So I'm going to go ahead and change that to 8. And then 20 can be simplified. You get 2 times 10, 2 times 5. So we can pull out a 2, and then that leaves a 5. Now I'm going to go back and reduce fractions. These 2's can cancel. So that just leaves me with radical 5 over 8. Now rationalize the denominator we don't have to worry about because we don't have any radicals in the denominator. And then just check your final answer. Make sure there's no more radicals that can be simplified or no more fractions that can be reduced. In this case there are not. So that's my final answer. Okay, this one I'm going to start by reducing fractions. Now, you can only reduce if they're both in the radical or both out of the radical. So for example, this 4 and the 48 we cannot reduce because one's in the radical and the other is not. We can reduce the 4 over 2 to 2 over 1. And we can reduce the 3 over 48 to 1 over 16. Now, let's simplify our radical. Square root of 1 is just 1, and 1 times 2 is just 2. And then the square root of 16 is 4, and then 4 times 1 is 4. Now we have another fraction to reduce because 2 over 4 can reduce to 1 over 2. And then we don't have to worry about rationalizing the denominator because we don't have any radicals left. So that is your final answer. This next example, again, I'm going to start by reducing fractions. Actually, I have to because neither one of those radicals can be simplified. But 10 and 15 can both be divided by 5. So we get radical 2. 10 divided by 5 is 2. 15 divided by 5 is 3. Now we have to rationalize the denominator. This step you don't ever want to start with. You do everything else you can first before you do that. Now rationalize the denominator means we get the radical out of the denominator. We can't leave a radical in the bottom of our fraction. We do that by multiplying the top and the bottom by the radical that's there. So we're essentially multiplying by 1, which doesn't change the value, but it will get rid of this radical. Remember, as we discussed before, radical 3 times radical 3 is the same as radical 3 squared. The square and the square root are inverse operations and cancel, leaving you with 3. So that makes our denominator a 3 instead of a radical 3. Then on top, we have radical 2 times radical 3, which is radical 6. And that would be your final answer. You do want to do one final check. Make sure there's nothing that can be reduced or simplified. In this case, there's not because that's a radical on top. So you can't reduce the radical with the whole number. Alright, for this last example, we do have a fraction that can be reduced. The 5's cancel. So now we have 1 over radical 3x squared, which we can simplify. The x squared can come out as an x, so we can change it to x radical 3. Now we need to rationalize the denominator, so we multiply by radical 3 over radical 3, And that gives us radical 3 over, remember radical 3 times radical 3 is 3, and then of course there's already an x there, so over 3x. And then do a final check, make sure there's nothing that can be reduced or simplified, and you cannot. The 3 over 3 cannot be reduced because one is in the radical and the other is not. So that is your final answer. Okay, for this next example, I'm going to again start by reducing my fractions. 6 over 10 will reduce to 3 over 5, and then the r's, I can cross this one and change that to 2. So r, not r, I told you that's gone, and then r squared. So just radical 3 on top. And then I can simplify this radical and bring the r out since it's an r squared. That means there's 2 of them. Now I need to rationalize the denominator. Since my radical on the bottom is radical 5, that's what we multiply the top and the bottom by. On top, that gives me a radical 15. Remember, on the bottom, the radicals cancel each other, leaving me with just 5, and then of course the r. Double check, see if there's anything else you can reduce or simplify. There is not, so that is my final answer. Okay, once again, I'm going to start by reducing fractions. So on top, 8 and 10 can both be divided by 2, which leaves me with 4, and on bottom leaves me with 5. Then the m, we'd have m squared on the bottom, and then the n's, we have one n on the top. Just 3 minus 2 is 1. Now simplify radicals. I know the square root of 4 is 2, so we can bring a 2 out. And we know the square root of m squared is m, so we can bring an m out. So that leaves me with 2 radical n over 3m radical 5. Now we'll multiply each by radical 5 to rationalize the denominator. So on top, that gives me 2 radical 5n. Then on the bottom, the radical 5's cancel, which gives me 5 times 3m, which is 15m. Then do a final check. Check your radicals, see if they can be simplified. Make sure you have no fractions that can be reduced again. And then that's your final answer.